This equation models the height of a tree t years after it was planted. And we're only looking at the first 25 years. A and B are constants, and we are given that the height of the tree is 260 meters 2 years after it planted, and then another information says that the height of the tree is 5.10 meters exactly 10 years after being planted. And I can see straight away that this is going to require simultaneous equations, because we're looking at values of A and B, so that's two variables, and we have two equations. And so at t is equal to 2 years, our height is going to be 2.6. Similarly, I'll just do it to the right over here. At t is equal to 10 years, the height is going to be 5.10. So we'll substitute these values into the equation, and the first equation will become 6.76, which is equal to 2a plus b. We do the same thing for the second half, and we get 26.01, which is equal to 10a plus b. And so we have equation 1, and we also have equation 2. And the method that I'll use for these two equations is to subtract the first equation from the second equation. And the reason I'm going to do that is because I have b here and b here, and once I deduct one equation from the other, the b will disappear. And so I'll write 26.01, which is equal to 10a plus b, and I will take away the equation 6.76, which is 2a plus b. As you can see, if I take away b from b, I will get nothing here. Anyway, 26.01, take away 6.76, will end up giving me 19.25, and 10 take away 2 is 8, and nothing for b. So that means that my a therefore is going to be 19.25 divided by 8, which is going to come out to be, we're told to put it to 3 significant figures, so that will have to be 2.41. Now I'll substitute a into the very first equation. This will give me 6.76 is equal to 2 times 2.48, which is going to be 4.82 plus the b that I want. So b is equal to 6.76, take away 4.82, which is equal to 1.95. And therefore our complete equation will be h squared, which is equal to at, where a is 2.41 t, plus b, where b is 1.95. Now the last part is, given that the tree was 7 meters, exactly 20 years after being planted, we can evaluate this model and find out whether indeed the height of the tree will be 7 meters. So let's try and find out what would be the height if after 20 years. So if I multiply that by 20, that means when time is equal to 20, we will find out what this means. and that means that h squared is equal to, when we do that calculation, we should get 50.15. Now we need to root this, and we only take the positive number because height is always positive, and that is going to be 7.08 meters. Now when you're measuring height of trees, I think that that is fairly accurate. I would say that it's very close to 7, so that model seems to be accurate. I hope you found this useful. And if you want to watch any more of my videos showing models of equations or specifically rate of functions, then please look up my channel, and also please try and subscribe and like my channels by putting the thumbs up.